This tutorial features mapping points at a global scale, and in this particular instance we're going to be using USGS earthquake data for a 30-day period. To get started, we're going to start with a base map, a very simple base map, and here you can see in my QGIS project I've started out with a feature called land and a feature called ocean, and I've symbolized them in a very basic format here. And importantly, I've also set up a spatial bookmark for this scale. So if I zoom in and I want to get back to where I was, I have that spatial bookmark set up. I've saved the project and I have a folder that I've also set up. So let me show you that. So under my USGS earthquake map folder, I have 110 million ocean, 110 million land features. I also have an empty points folder, and I have the QGIS project saved. So that's kind of the basic structure to set up on. And the download for the base map comes from Natural Earth for the physical features at small scale. So if you click on the physical features, there is land and also ocean here. Okay, let's start with the data. We need to do a data download to get points into our map. And the process that we're going to use is CSV file. And we're going to map the XY coordinates within QGIS and plot them on the map. And at that point in time, we'll be able to go ahead and symbolize them based on magnitude. So that'll be the next step once we actually get the points onto the map. So first thing we want to do is get the data downloaded, get it ready for QGIS, and bring it into QGIS. So to get started here, we're going to search within the USGS shake map data. And there's a couple ways to get into it, but once you're into it, it'll look something like this. And we want to first search on magnitude. So we're going to use a low magnitude because we want to show a lot of earthquake points on our base map to show the pattern of earthquakes and earthquake faults. Remember, we're dealing with a global scale, so we're not necessarily interested in one particular quake or in a large-scale mapping of the ramifications of a particular quake. We would just want to see the larger pattern. So our minimum is going to be 2.5. It's going to be the past 30 days. Okay, so we'll click on date and time past 30 days, and our scale is going to be world. Under advanced options, we want to just go ahead and get any type. So advanced options, event type, we're going to do earthquakes. So we could also add non-earthquakes if we want to, but in this case, I just want to do event type earthquakes. These are pretty interesting categories here, so you might want to explore this at a later date. Under impact, we're going to choose any. Under catalog, it's also going to be any. Under contributor, it's going to be any. Under product type, it's going to be any. And output options, we can output to GeoJSON or KML, and that'll work well in QGIS, but we want to practice bringing in tabular data into QGIS. So we're going to click on CSV, and we're going to download it. So as we download it, we should get a fair number of records. So let's take a look and see what we got. So here I have 2,609. If you're getting down into the 200s and 300s, you may have clicked on 7 days, and you just need to go back and do 30 days. So a 30-day period, you should be getting into the thousands at the start of 2.5 magnitude. So I'm going to go ahead and just cut this out and put it into my folder. So I'm going to go into my global scale folder and put it into points. So it's going to be sitting here. And remember, it's a CSV file. So now what we need to do is we need to get into QGIS and actually set up to map this. And the way that we do that is to actually map the XY coordinates of the tabular data itself. There's two ways that we can bring in tabular data into QGIS. And the first way is we can simply browse through our browser panel and actually go into our folders. So I have it saved as a favorites here, and I can see my points folder. And if I just click on my query, I can say add layer. And if I go to layers panel now, here it is sitting right there. And I can go ahead and open that up like any attribute table, and there it is. And we can see our latitude and longitude column. So that's one way to bring tabular data into a mapping session, especially if you're going to be joining this data with spatial features. But another way that we can do it, if we know that we're going to bring it in, especially for mapping XY coordinates, is we can use this icon on the left-hand side here for a text delimited text file where we're actually going to create a layer from it. So again, it's this one right here that's number 3 from the bottom. We click on it and we can just browse to our location of our data. And it shows the name. Everything looks good so far. The file format, we can click on it as CSV if we want to. Okay. And what we want to do now is we want to tell it what's latitude and longitude. So under the geometry definition, it's going to be point coordinates. In our X field, it'll see these if they're named something that it resembles latitude and longitude. If it's named James and Susie, it's not going to be able to know, and you're going to have to point it to that. So for my X field, of course, I want to have longitude, and my Y-axis, I want to have latitude. And everything looks good there. We should be able to go ahead and map this and just say OK. And that looks correct. If you get that warning that just came up, I don't know if you saw it real quickly, but it said, listen, I'm going to use as default WGS 84 as the coordinate system to do the actual points layer. That's perfectly fine. You don't want it to be anything else. You want it to be in WGS 1984. So if we go to query and go down to properties now that we have a feature, and we take a look at the general column, we should see the coordinate system be WGS 1984. If that's not the case, then you need to back up and make sure that you have that option available to you, because we always want to be mapping latitude and longitude, especially coming from something like ShakeMap, to WGS 1984, unless we know it's coming from some other datum. But for the most part, you can assume that it's going to be coming from WGS 1984. Okay, so here's our points, and they look like they fall within a fault pattern. So we see a lot of activity in Southeast Asia. We see a lot of activity in the Caribbean and in Central America. We also see quite a bit of activity in Alaska. What's interesting is that there is a lot of activity that takes place around Oklahoma because of the fracking quakes, but maybe our magnitude just didn't pick up because we remember we chose a magnitude of 2.5. And it looks like there's even, let me put this on top here. Oh, excuse me. What I did is I had the query sitting underneath land. So, oh, this makes a lot more sense. So there's all the Oklahoma quakes right here. You can see that little section right there. And then a few days ago, there were a couple quakes that were on the East Coast, and so those are showing up also. So great. Make sure that you have your points sitting on the top. So now, because I have my spatial bookmark, I can go ahead and click on that, and that's going to bring me right back up to my front page. So our task now is, now that we have all these points sitting here, is to actually go ahead and symbolize them proportionally. And that's going to be a bit of a trick, and we'll spend some time in another video doing that together. One thing that's going to be an issue that we should point out before we get too much further is when we do our final map sheet, we're probably going to have a couple of these points clipping off right at the edge. So just be aware that the way that we're going to set up our map sheet, it's going to be a full bleed to the edge, and we're probably going to miss a few of these quakes. But remember, at this scale at which we're mapping, which is this global scale, we're more interested in the larger pattern of the points than we are with any one particular point. So we can go ahead and accept that compromise for this particular mapping that we're going to be able to, that we're going to do. So at this point, just make sure that your query feature, you do a save as, and we want to make sure that it's WGS 1984, EPSG 4326. We're going to browse and stick it in our desktop under points, and let's export it out as a shapefile, and I'm going to call it Quake points, Quake underscore points, and say save. Okay, so now I've solidified them as geometry, as shapefile geometry in WGS 1984 with all the points. And importantly, now we have a nice attribute table. So if we go to the attribute table, here it is, and we can see 2608 records, and we have several different columns that we can map on. We're going to be utilizing for the most part the magnitude column right here.